Welcome to Module 15, Securing Windows. This module covers essential logical security concepts, Windows security settings, and managing Windows shares, all of which are core skills for the CompTIA A+22 01202 exam. By the end of this module, you will be prepared to configure and troubleshoot Windows networking, manage security settings, and handle Windows shares. Lesson 15.1 focuses on logical security concepts. This content maps directly to CompTIA A plus exam objectives 1.5, 2.1, and 2.2, covering command line tools, security measures, and OS settings. In this lesson, we will explore the CIA Triad, identity and access management, the differences between local and Microsoft accounts, just-in-time access, and the zero trust model. The CIA Triad is the foundation of cybersecurity. Confidentiality ensures data is private, integrity ensures it is accurate, and availability ensures it remains accessible when required. Identity and Access Management, or IAM, controls access to resources by verifying user identities and granting permissions. It aims to secure access without hindering productivity. A local account is device-specific with locally stored credentials. In contrast, a Microsoft account is cloud-based, providing seamless synchronization of settings and apps across multiple devices. Just-in-time access grants temporary time-limited administrative privileges only when needed. This approach significantly reduces the risk associated with persistent, always-on administrator accounts. Zero Trust operates on the principle of never trust, always verify. It requires continuous authentication and authorization for every user, device, and connection, regardless of whether they are inside or outside the network. This lesson further details logical security controls, information security policies, encryption concepts, digital signatures, account management, and authentication methods. Logical security controls, such as firewalls and encryption, protect systems from unauthorized access. These are complemented by administrative and physical controls to ensure comprehensive security. Information security relies on clear policies for hardware, software, and users. Assessments identify vulnerabilities and threats to help reduce potential risk and impact on your organization. We differentiate between symmetric encryption, which uses a single key, asymmetric encryption, which uses a mathematically linked key pair, and cryptographic hashes, which provide a short representation of data for integrity. Symmetric encryption is fast and efficient for bulk data. Common algorithms include the secure AES and the older, less secure DE. It functions like a box with a single physical key. As you can see, symmetric encryption uses the same key for both the encryption of plaintext into ciphertext and the subsequent decryption back into plaintext. Asymmetric encryption uses a key pair, a public key to encrypt, and a private key to decrypt. While slower than symmetric methods, it is highly secure for key exchange and identity verification. In this process, the public key is shared openly for encryption, while the private key remains strictly secret for decryption, ensuring only the intended recipient can access the data. Cryptographic hashes create a unique, fixed-length digital fingerprint of data. This one-way process cannot be reversed, and any change to the input will change the resulting hash completely. This diagram illustrates the hashing process. Data is fed into a function, such as SHA-2, which produces a distinct output, verifying data integrity. As shown here, the hash acts like a digital fingerprint. Even the slightest alteration to the input results in a completely different hash output, which is ideal for verifying file integrity. Hybrid encryption combines symmetric speed with asymmetric security for large files. We also use digital signatures to verify sender identity and key exchange protocols to establish secure communication. Managing users effectively requires understanding local versus Microsoft accounts, built-in security groups, and tools like lusrmgr.msc or command line utilities to maintain system access control. User Account Control, or UAC, helps enforce the principle of least privilege by prompting for administrative approval before tasks that could modify system settings can run. This visual shows the standard Windows UAC prompt, which ensures that administrative actions are intentional and authorized by the user. Authentication security is bolstered by multi-factor authentication, or MFA. By requiring factors like something you know, have, or are, we add layers of protection beyond simple passwords. Finally, one-time passwords, authenticator apps, and physical hard tokens provide robust ways to confirm identity, significantly reducing the risk of unauthorized account access. Lesson 15.2 Windows Security Settings. This lesson maps to the same 3A+2201-202 objectives, 1.5 Command Line Tools, 2.1 Security Measures, and 2.2 Windows OS Security Settings. By the end of this lesson, you should be able to answer: what principle states a user should get the minimum rights necessary for their job? When are security groups typically used? What command adds a new user and forces a password change at first login? What are the types of authentication factors? Which Windows login option uses a PIN, biometrics, or a security key? And what software applies security policies to mobile devices in the enterprise? That's the principle of least privilege. Users should only have access to the resources and data required for their job duties, reducing the risk of data leaks and accidental system changes. A receptionist, for example, doesn't need admin rights to install software. Security groups are used when multiple users need the same permissions, common in Active Directory environments. It's easier to manage access by assigning rights to the group rather than individuals, like an accounting group with access to finance shared folders. The command is netuser, followed by username and password with add/logonpassword chg-yes. This forces the user to change their password at first login, commonly used by administrators setting up new employee accounts. The authentication factors: something you know, like a password or PIN; something you have, like a phone, smart card, or key fob; something you are, like a fingerprint or facial recognition; somewhere you are, like GPS location; and something you do, like typing pattern or gesture. That's Windows Hello. It allows sign-in using a PIN, facial recognition, fingerprint, or a physical security key following the FIDO2 standard, improving both convenience and security through local authentication instead of reusing a cloud password. That's Mobile Device Management, or MDM, software. It lets administrators enforce passcodes and encryption, control app installations, and remotely wipe lost or stolen devices. Examples include Intune and Mobile Iron. Here's what this lesson covers: Windows login options, Windows domains and Active Directory, and group policy and login scripts. Time for an activity. Configuring Windows security settings. Enable and configure user account control, set up a Windows Hello login option, configure a group policy to enforce password complexity, and enable and test multi-factor authentication. Username and password is the traditional method for local and domain logins, least secure if reused or weak. Windows Hello uses biometric or PIN-based authentication, a PIN stored locally, fingerprint or facial recognition using built-in sensors, or a hardware-based FIDO2 security key. Single sign-on lets you log in once to access multiple systems, reducing password fatigue, common in enterprise networks using Azure AD or Microsoft 365. SAML, Security Assertion Markup Language, is an XML-based standard for federated authentication, letting login credentials be trusted across domains, like logging into Office 365 with a company account. Domain controllers are central servers that authenticate users and computers, store and manage the Active Directory database, and enforce group policies and security settings. Member servers are joined to the domain, but don't manage authentication. They provide shared services like file storage or printing. Security groups simplify permission management by assigning access rights to multiple users at once, like a finance group. Organizational units are subdivisions within a domain for departmental management, applying specific group policies to groups like IT, HR, or students. A domain group policy object is a centralized tool for enforcing settings on users and computers, controlling security options, software installs, password rules, and desktop environments, applied automatically at logon or startup. To update group policy, gpupdate/force immediately refreshes applied policies, and gpresults/r shows which policies apply to a user or device, useful for troubleshooting conflicts. Login scripts run automatically when users sign in, configuring drives, printers, map locations, or environment variables, written in batch files, PowerShell, or VB script. Here's what group policy management actually looks like. Notice the policy structure and the settings you'd configure to enforce rules across the domain. Lesson 15.3. Windows Shares. This lesson maps to 3A plus 2201202 objectives. 1.5. Command line tools. 1.7. Configuring Windows networking features. And 2.2. Windows OS security settings. By the end of this lesson, you should be able to answer: what network type must be selected to make a computer discoverable and allow sharing? What tab in a folder's properties dialog customizes permissions and share name? What's the process to map a network drive? Which permissions take precedence? Explicit deny or explicit allow? And what is a home folder? Windows networks can be set as public, private, or domain. To enable sharing and discoverability, select private or domain if joined to one. That enables network discovery and file/printer sharing. Public networks disable discovery for security, like at a coffee shop. In a folder's properties, the Sharing tab, click Advanced Sharing to set the share name, limit simultaneous connections, and configure permissions, read, change, or full control. Use the Security tab separately to manage NTFS permissions. To map a network drive, open File Explorer, go to This PC, Map Network Drive, choose a drive letter, enter the UNC path like 2 / server name / shared folder, check Reconnect at Sign In if desired, enter credentials if required, and click Finish. Shortcut: use Net Use Z, followed by the UNC path and command prompt. Windows permissions combine NTFS and share permissions. Explicit deny takes precedence over explicit allow. If a user has both, access is denied. The rules: explicit deny overrides everything else. Explicit allow overrides inherited deny, and inherited permissions are secondary to explicit ones. Always review both the share and security tabs for conflicts. A home folder is a personal network directory for each user, storing personal documents and settings with automatic redirection to a user-specific location. It's configured in Active Directory under User Properties, the Profile tab. A typical path looks like a server path ending in users, then the username. Time for an activity: configuring Windows shares. Create a shared folder and set permissions for specific users. Map a network drive to it. Configure NTFS permissions and test access from another user account. Here's what this lesson covers: workgroup setup, file share configuration, network browsing and mapping drives, printer sharing, NTFS versus share permissions, permissions inheritance, domain setup, home folders, and roaming profiles and folder redirection. New PCs are automatically assigned to the default workgroup. Change the computer name or workgroup through System Properties, the Computer Name tab. A restart is required after changing membership. Enable network discovery and file sharing through Control Panel, Network and Sharing Center, Advanced Sharing Settings, turning on network discovery so PCs can see each other, and file and printer sharing to enable resource access over the LAN. The public folder lets all local and optionally network users read and write files. Enable it through Advanced Sharing Settings. It's ideal for simple home or small office networks, but not recommended for sensitive data. To share a specific folder instead, right-click, give access to specific people, choose a user or group, and assign read or read/write permissions. Shared folders appear under the computer name and share name on the network, and you can manage finer control through Properties, Sharing tab, Advanced Sharing. To share a printer, open Control Panel, Devices and Printers. Right-click the printer, Printer Properties, Sharing tab, check Share this printer, and give it a recognizable name. Optionally install additional drivers for other Windows versions. To connect from another PC, open File Explorer, Network, locate the host computer, right-click the printer, and connect. Windows downloads drivers automatically if available. Best practice: use descriptive names and make sure both PCs are on the same network. Share permissions apply only when files are accessed over the network, controlling access to the shared folder as a whole, read, change, or full control. NTFS permissions apply to both local and network access, offering fine-grained folder or file-level control, including modify, read and execute, write, and full control, stored in the file system's access control list. When both apply, the most restrictive permission wins. If share is full but NTFS is read, the user only gets read. To recap, share permissions are the simpler, network-only layer, while NTFS permissions are the fine-grained layer that applies everywhere, local and network alike. Whenever the two combine, the more restrictive one always wins. That's the rule to remember. Here's what those two permission sets actually look like side by side in the Properties dialog: the Sharing tab controlling share permissions, and the Security tab controlling NTFS permissions. NTFS permissions assigned to a parent folder are automatically inherited by its subfolders and files, simplifying management, though it can be disabled for finer control. Administrators can break inheritance to customize permissions on specific files, converting inherited permissions into explicit ones or removing them entirely. When share and NTFS permissions combine, the most restrictive one takes precedence. Real-world example: a shared projects folder inherits permissions for the whole team, but its finance subfolder disables inheritance to restrict access to accounting staff only. When a computer joins a domain, it falls under centralized management by domain administrators through Active Directory, with policies, software, and updates deployed automatically. Each computer needs a unique domain account to authenticate, stored in Active Directory users and computers. The system must be on the domain's network and able to resolve the domain name via DNS, typically configured automatically through DHCP. To join, System Properties, Computer Name, Change, Domain, then provide domain credentials. This requires Windows Pro, Enterprise, or Education, since home editions can't join domains. A home folder is a private network drive mapped to each user for storing personal files, centralizing data on the server instead of local machines to improve backup, management, and security. In Active Directory users and computers, set the home folder path under the user's profile tab. When the user logs in, Windows automatically maps it as a network drive, like an H drive, and administrators can use group policy to redirect folders like documents and desktop into it for consistency. The key benefit: user files stay with their account no matter which workstation they log into. A roaming profile stores a user's desktop, settings, and documents on a network share instead of the local PC. Windows downloads the profile at login and uploads changes at logoff. Advantage: consistent experience across any domain computer. Drawback: large profiles slow login/logoff and use more bandwidth. Best combined with folder redirection. Folder redirection sends specific folders, like documents or desktop, to a network share instead of the local drive. Controlled through group policy, though those folders are only accessible while connected to the network, unless offline files is enabled. To wrap up Module 15, IT technicians use their knowledge of logical security controls to manage secure user and group accounts. Understanding the different areas of Windows security is crucial to ensuring users have the access they need and nothing more. And differentiating between NTFS and share permissions and knowing when to use each is crucial to managing user accounts effectively.